Module 11, first video. In Module 11, we're going to discuss scatter plots and correlation coefficient. First, just notice what's going to happen in this unit is we're going to be looking at an observational unit, and instead of writing down one piece of information about that observational unit, instead of identifying one variable related to that observational unit, in this unit, we're going to actually talk about gathering two quantitative variables related to that observational unit. For example, perhaps the observational units are students at DCC. I may then go up to each observational unit, meaning I go up to each student and I gather their height and also the student's weight. That would be two quantitative pieces of information about each observational unit. Once I have those two quantitative pieces of information, I would have two numbers for each student. We refer to one of those values as the explanatory variable and one as the response variable. Remember, we discussed that back in Module 10. We would then organize each of those two pieces of quantitative information as a point, an ordered pair, where we'll put the explanatory variable value in the first coordinate and we'll put the response variable value in the second coordinate. So for example, I might have a student who is 61 inches tall and weighs 135 pounds. So the point related to that observational unit would be 61, 135. Okay, so after I've gathered a whole bunch of students, and for each student gathered two pieces of quantitative information, I would have a whole bunch of points. So from those points, we are often going to organize and think about the pattern in order to try to understand if there is a correlation between the explanatory and response variable. We are going to create a scatter plot that organizes all those points. And then the four things that we're going to ask you to consider about the scatter plot are the direction of the scatter plot, that is, whether it is generally increasing or decreasing. The form of the scatter plot, what we're really interested in our unit, is whether or not it takes on the pattern of being linear, like a line, or not. The strength, meaning how closely does that scatter plot resemble a linear pattern, a line, and then whether or not it has any unusual observations, outliers. Correlation coefficient is a number that helps us understand if a linear graph is strongly correlated with our data, or weakly correlated with our data, or moderately correlated. So a correlation coefficient, it's this number. So first of all, if a correlation coefficient were actually equal to exactly 1, if that happened, then that would mean that your points that you gathered from your data, your scatter plot, is exactly a straight line that's increasing. If you had a scatter plot like that, then the correlation coefficient would be exactly equal to +1. If you had a scatter plot after you gathered your data, and your scatter plot was a perfectly straight line that was decreasing, then that scatter plot would have a correlation coefficient equal to -1. And if your scatter plot was just random dots all over the place with absolutely no resemblance to a linear pattern, the explanatory and response variable have no association, no correlation, then that would have a correlation coefficient of 0. Now, in reality, when we go out and we collect a sample, or even if we look at the entire population, you're not going to get correlation coefficients equal to +1 or -1 or exactly 0. In fact, what we'll always tend to get is correlation coefficients somewhere between -1 and +1. But the pattern still holds. The closer your correlation coefficient is to +1, the closer your scatter plot is to looking like a straight line that's increasing. The closer your scatter plot is to looking like a straight line that's decreasing, the closer your correlation coefficient will be to -1. And the closer your scatter plot is to just being random dots all over the place, the closer your correlation coefficient will be to 0. Correlation coefficients close to -1 or +1 means there is a very strong correlation between data and a straight line. Remember, +1 being an increasing data set, -1 being a decreasing data set. And the closer your correlation coefficient is to 0, the closer your data set is to being a scattered random mess with no association. So we would say that's very weak correlation. Positive correlation coefficient definitely means that in general, your data tends to be increasing. Negative correlation coefficient means that in general, your data tends to be decreasing.